Hi there, we are going to get started with the guided practice 3 from section 1.4 on fractional expressions. We've got 4 examples to go through here, and we start with one involving division. So whenever we think about division, the first thing that we're going to do is convert this to multiplication of the reciprocal. So we're going to keep the first fraction. So that means we're keeping the x squared minus y squared over x squared plus 3xy plus 2y squared. So we're keeping that one as is. We're going to switch the division to multiplication, and then we're going to flip this fraction over. So then we're going to move the x squared minus 9y squared to the top, and the x to the fourth plus 2x cubed y plus 3x squared y all moves to the bottom. Okay. All right, now our next game plan is to factor this as much as possible. Okay, so let's start in the upper left-hand corner with the x squared minus y squared. This is going to be a difference of two squares, right? This x squared is a square and y squared is a square. So it's going to get factored, the square root of both. So we have x and y, and we're going to have plus and a minus. Okay, on the bottom, if this one throws you for a loop, take out the y's. If you take away the y's for a second, it looks like this. And that one we can factor. We're looking to find two numbers that multiply to 2 that add to 3, and that's just going to be 2 and 1. So 2 times 1 gives you 2, but 2 plus 1 gives you 3. And so we're going to use that as the way we factor. So it's going to be x plus 2 and x plus 1. But because there's a y here and here, we put a y in that second spot. So it's going to look like this. Okay, and if you check, you can see that that's exactly what you get. Over here on the right, we've got x squared minus 9y squared. So let's take a look at this one. And those are both squares again. So the x squared is a perfect square and 9y squared is a perfect square. So this is a difference of two squares. And then we want to think about the square roots of each part. So the square root of x squared is x, and the square root of 9y squared would be 3y. And that means that it's going to factor as x plus 3y and x minus 3y. On the bottom, the first thing I'm going to do is look for, there's a bunch of stuff going on, so the first thing I'm going to do is look for something in common. And I notice that they all at least have 2 x's, so I'm going to go ahead and pull an x squared out front, and that's going to leave me with x squared plus 2xy plus 3y squared. Okay. And again, let's think about this one as without the y. So x squared plus 2x plus 3. Now I'm looking for two things that multiply to 3 but add to 2. Well, the only things that multiply to 3 is 3 and 1, or negative 3 and negative 1. And so we're not going to be able to find a number that works here. So that means that we're not going to be able to reduce that. Okay, so we're going to leave it just as it is. Oops. There we go. Okay, now that we have it nice and factored, we're going to say, okay, is there anything we can cancel? Well, did I copy this wrong? No, I did not. Okay, I was just looking for more things to cancel. Let's see, does anything cancel? I see an x plus 1, y, that will cancel top and bottom. Yeah, that's about all I'm seeing. So that means when we put this all back together, this is x minus y times x plus 3y times x minus 3y. On the bottom, we have the x plus 2y from the fraction on the left, and x squared, and then the x squared plus 2xy plus 3y squared. And that's going to be it. We can't do anything else to simplify that one, so we're going to leave it just as it is. So we're done. Moving on to letter B. Here we've got one where we are adding two fractions, and so we need to get common denominators. So before we do that, let's go ahead and factor. So we're factoring the denominators. The x on top can't be factored. On the bottom, we've got a difference of 2 squares. So that's going to give us x plus 1 and x minus 1. The fraction on the right, we've got 2x plus 3 up top, and we're factoring the bottom. So we're looking for two factors of -3 that add to +2. So for -3, we really only have -1 and 3, and -3 and +1. But if we add them to get +2, we would need this one, right? This one gives us -2. So that means we're going to factor that as x minus 1, x plus 3. Okay. Now, the next thing we want to do is to find our common denominator. And when I look here, I can see that I want to take all of this. So I want x plus 1 and x minus 1 to be part of my common denominator. Then when I look at the second one, this piece, the x minus 1, it's already there. So I don't need to rewrite it. I'm going to use the one that's already in there. So all I have to put in there is the x plus 3. Now, how do I compensate for the fact that I changed the denominators? Well, on this side, what I did was I multiplied by x minus plus 3. So I'm going to have to do that on the top and the bottom. So I will have x times x plus 3 up in the numerator. On the right-hand side, we multiplied by x plus 1. So we're going to do that top and bottom. And that's going to mean that I end up with 2x plus 3 times x plus 1 in the numerator. Okay, let's go ahead and combine it all into 1 so I can write that denominator only one time. Right? Because when we add two fractions that have the same denominator, we keep the denominator and we add what's in the numerator. So we have x times x plus 3 plus 2x plus 3 times x plus 1. Now you could multiply out the numerators before you combine them. That's up to you. Now what I'm going to do is go ahead and distribute and simplify. Right? And so we're going to FOIL these out. And that's going to give me an x squared plus 3x plus, now the first two would give me 2x squared. The outside is going to give me 2x. The inside is 3x. And the last is 3. All over that common denominator. And again, you don't have to, if you want to multiply all that out in the denominator, go for it. I like to leave it factored. Then we combine like terms. So I see 2x squared terms. That's going to give me 3x squared. I see 3x terms, a 3x, and a 2x. It gives me a total of 8x and a plus 3, all over that common denominator. And that is my final answer. All right, on to fractions and fractions. Okay, now my objective here is to clear out my smaller fractions. So that means I want to get rid of this denominator and this denominator. Luckily for me, they're both the same. So I can multiply the top and bottom of my big fraction by x plus 2. And if I do that, I will clear those smaller fractions out. So when I do that, I need to multiply that times the 2, okay? And so that's going to give me 2 times x plus 2, minus, then I distribute it and multiply it by this fraction. Well, when I multiply it by that fraction, the x plus 2's cancel, and I'm left with just x. On the bottom, I'm distributing that x minus x plus 2 over here. In that case, the x plus 2's cancel, and I'm left with just a 3. Minus, then I'm distributing it here. So 4 times x plus 2. Make sure you keep that in parentheses. And then all I have to do is go ahead and distribute and combine like terms. So if I distribute up top, that's going to give me the 2x plus 4 minus x. And on the bottom, I'm distributing the 4. So I'm going to have 3 minus 4x. Don't forget to take the negative with you. Negative 4 times 2 is minus 8. And then we can go ahead and combine our like terms. So 2x minus x gives me x plus 4 in the numerator, and negative 4x minus 5 in the denominator. Okay, now if you wanted to, you could go and get common denominators in the numerator and the denominator of the big fraction, and then cross multiply, do all the things, but I really think it's easier if we go ahead and just clear our fractions, the small fractions. All right, and then we're going to rationalize the numerator here. So they want us to focus on the numerator and rationalize it. So that means we're going to multiply by the same thing, so square root of x and square root of 3, but with the opposite sign, so with a plus sign in the middle. And we're going to multiply the top and the bottom so that we keep it balanced. And then we're going to see what happens. Okay, so here's what we get. When you multiply in the numerator, the first two is going to be square root x times square root x, which turns out just to be an x. Your outside is going to be plus root 3 times root x. Your inside is going to be negative root 3 root x. And your last is going to be negative, because you have a negative times positive, and root 3 times root 3 is just 3. On the bottom, we're going to multiply the x squared times everything over here. So that means we're going to get x squared times, and actually, I think what I'm going to do is I'm going to leave it factored for now. X squared minus 3 times root x plus root 3. I think I erased a 3 over here. Okay, and so what happens is that these two terms cancel out, and we end up with just an x minus 3 over an x squared minus 3 times square root of x plus a square root of 3. And we can leave it like that. If you want to go ahead and multiply it out, you can in the denominator, but it's actually going to probably end up pretty yucky looking. So we're okay leaving it just like that. And we're going to end here.